All right, chapter 5. Understanding and comparing distributions. All right, box plots or box and whisker plots are a way to visually display quantitative data. Before we make a box plot, we need to determine if we have outliers we use the 5-number summary and IQR to do this. Example, using 1.5 IQR to determine outliers. Okay, so we do 1.5 times the IQR is what this means.
Isn't IQR the quartile 3 minus quartile 1?
Yep, Q3 minus Q1. So here is a 5-number summary. Max 8.67, Q3 2.93, median 1.90, Q1 1.15, and the min 0.20. So like she said, the IQR is Q3 minus Q1, which in our case is 2.93 minus 1.15, and that's equal to 1.78. So now is the new stuff, okay? So to determine the range, for reasonable data, okay, or the fences as we will commonly call them, we're going to find two different things. Okay, we're going to do Q3 plus 1.5 times the IQR, and we're going to do Q1 minus 1.5 times IQR. Make a note of these signs, okay? I'm trying to find the farthest out that I can go before I consider something an outlier, okay? So on the high end, I want to add 1.5 times the IQR. On the low end, I'm going to do Q1 minus the the 1.5 IQR, okay, to give you your total range that you're dealing with. Okay, and anything outside of that range is not reasonable data to be dealing with, okay, is what that means. So for our particular case here, okay, using our 5-number summary that's listed in the IQR that we already found, we are going to do Q3, so 2.93 plus 1.5 times the IQR was 1.78. Okay, do not round this IQR. Leave it as is. Okay, now, here's what I will say. Sometimes when you do your 5-number summary, it doesn't just give you out to 2 decimal places. Okay? For this stuff, when you're doing this IQR, go to 2 decimal places. Okay? Do not round to anything less than 2 decimal places or it will be wrong. Okay? So then we could, okay, remember you've got to do this multiplication first or your answer will also come out to be wrong. Okay? Don't forget PEMDAS just because we're in stats class. Okay? So this comes out to be 5.6. Okay, it came out to be an even 5.6. And then over here, put in Q1, which is 1.15 minus 1.5 times 1.78. And when you do that one, you get negative 1.52. All right, so I'm going to write a little bit here about what this means. So these numbers tell us that it would be, or it would not be, unusual to find data values between negative 1.52 and 5.6. Anything outside of this range, okay, again, remember we're calling them fences, can be considered an outlier. So based on that, do we have any outliers in our data, just from what we can see?
No. Yes.
Okay, why?
Because the max is higher than 5.6.
Okay, the max is higher than 5.6. Okay, so from that, we can then conclude that our data set has at least one outlier. Okay, why would I just say at least one?
Because we don't know if that's the biggest one. Like, we don't know if there's more in between.
Okay, yeah, we don't know if there's more in between that Q3 and that max value. Okay, there could be more. If you were actually given a set of values that you found the 5-number summary for it yourself, you can go back and look and see how many are in that. But this one, they just gave you the 5-number summary. Sometimes it will just tell you, here's your 5-number summary. Do you have outliers? Sometimes it'll say, here's a whole bunch of data. Find the 5-number summary, and then tell how many outliers there are, if there are any. Okay? Berkeley, did you have a question?
No, I understood because you technically, your Q3 can't be an outlier because that's what's inserted to the problem.
Correct. Okay. Okay, this one outlier is the max. Okay, but there could be more. Okay, as we just explained. How far up can I go?
I'm done.
Everybody good? Okay. I can go pretty far then. All right. What? Okay. All right. So the next thing is if you don't have at least like probably 7 or 8 lines, I would go to a new page. Or you're not going to get all of this next material on it. For me, it's like a half a page, but I'm also writing on unlined paper, so I'm kind of just writing all over the place. So, anyways. All right. A box plot is constructed to look like this. Okay, I am not using the data from the previous problem. I'm purely just drawing an example of what it looks like. Okay, so draw a really long line and go in increments of 100 from 0 to 500. All right, now you might want to wait till I draw this part before you try to draw it. This is just going to be irritating, so just
Are they supposed to be the same size?
no, they're supposed to be different. It's just the one is going to look nice and neat, and the other one's just not going to because it's not going to connect them together, and it's fine. I guess I could theoretically do it this way. Hold on. Okay. And then draw these.
How many lines did you say we might need?
Probably like 8.
Does it matter how many, like where the lines on the sides are, like within the box plot?
These?
Yeah.
No, just relatively close. I mean, it doesn't really matter because this isn't real data. I'm purely just drawing a picture, but... And while you're drawing this, another thing I'll say about these is that they don't have to go side to side like this. Sometimes they'll go up and down. Okay, it doesn't matter which way they're drawn. Their principle is the same.
It's kind of chilly.
I thought it was warm earlier, but now I feel like it's like, I don't know. I saw several people last class go get their sweatshirts, and I was surprised I haven't needed one yet.
I don't have a Denby sweatshirt.
You will soon.
I will soon. Thank goodness. I don't think I could make it the whole school year without being able to put one on. It's cold. And like both of the buildings are really cold.
All right, do we all have this drawn?
Yeah.
Okay. So Q1, median, Q3.
Should have left space above it.
You can write it below it, it's fine.
Really awesome.
Yeah, that's fine. Okay, this whole area here in this box is the IQR. Whoa, stop that. So in case you didn't get the whole like box and whisker thing, okay, it's the box with the little lines coming off of it. It kind of looks like little cat whiskers.
Are you talking about like the little stars on
These? No, these out here. The stars are outliers.
So those are like the ones that you know are outliers?
Yes, because they're going to be outside of the fences, and I'll explain that in just a second. Alright, so these two, the straight up and down lines that are way out, okay, on the whisker part, okay, these lines, okay, and you can just literally write wherever you have space. I'm just, like I told you, I just write all over the place, so just bear with me. These lines are either the min and max or the closest data values inside the fences something else to note, they are not the fences. They are just guidelines. Okay, I'm trying to get this so it doesn't have a weird glare on it, and then I'll move it back down and we'll talk about it for a second. In the library to get it all written down first though.
Is that all already written? Is that like this?
On the picture, yeah, I think.
So those are the 7 lines?
Yeah. Yes. And then I'm going to write one more thing about box plots in just a second, but that's probably going to be like 3 lines, I think.
Is that going to be it for notes for today?
No, there's like another page of them.
I just didn't want that to be like
And then I may go to the book and pull a couple examples and then go over the, I'm not sure. I have to see if I can get the worksheet up and to actually print, because the other day it was having problems. It doesn't like me right now. Microsoft doesn't like me, and I keep forgetting that. I have to go import it into things, and it's irritating.
Very aggravating that I had 6 lines, so I couldn't have done it on.
Oh, yeah. You could always go back and write the next thing on
Yeah,
the
I
other
know what I'm
page,
gonna
because
do.
then it's still about box plots, so it doesn't matter.
It looks so awkward. It's like.
Yeah, you definitely could fit the other thing that we're going to write in just a second on it. Does everybody have this down so we can discuss this part? Just want to make sure that we're clear here on what's going on. Okay, so, okay, inside that box, okay, that's your IQR, that's your interquartile range, your Q3 minus your Q1. So sometimes they'll give you a box plot like this, and they'll ask you what the IQR is. And so again, with this one, we'd be approximating. Okay, this is probably something like 375, okay, down to like 175. Okay, so it may ask you what your IQR is, and you could kind of guesstimate from that. Okay, because all the pictures in the book will not be perfect. It's an estimation thing. Don't let it stress you out if your answer's not exactly what the book is. Okay. once we found the outliers by doing the Q3 plus 1.5 IQR or the Q1 minus 1.5 IQR, okay, we can then determine where our whiskers are going, okay? If our max and min values are inside the fences, these whiskers occur at our max and min values, okay? If our max or min values are outside of the fences, okay, like in the problem that we looked at a minute ago, then we pick the closest data value given to us that's inside the fences if you're given a list of data. My rule is if you were not given a list of data, let's say you were just given that 5-number summary, right? Your fences will be your whiskers if you have a max value outside of the fences. Does that make sense? You understand? Okay. It may be that your min value is in it, but your max value is not. So again, if you're given a 5-number summary, go with the fence value. If you're given a list of data, you pick the value closest to, but inside the fences. Okay? Does that make sense? It'll make, if it doesn't quite, it will once you see examples. Okay? Okay, the outliers we represent with a little star or some kind of little shape like that. Sometimes you'll just see them as a dot in the book. Okay, so if you see that, that's what they represent. On occasion, some things, I don't think our book really does it, but every once in a while you'll see one where they'll actually put the outliers inside the whiskers because they leave the max value even if it's not. Like it's just kind of weird. So on occasion you may see that, but typically it's going to look like this. Okay? All right. Awesome. Any questions about these, drawing them, anything like that at this point? All right. So, box plots help you see the middle 50% of your data, and they can be especially helpful for comparing multiple, I don't know why, what am I writing right now? We're just gonna not talk about that. Multiple distributions. You can see the medians, mins, and the maxes, okay, etc. You can see all the different stuff on them and compare visually. So like with the one that we just drew, I'm going to go up here and try to leave it so you can see that bottom part, okay? I could have said, okay, this was the number of people in attendance at all the home games this year. Okay, obviously that's not accurate, but I'm just saying I could do that. And then I could say, I could do a side-by-side with all the away games and see what the comparison was for how many we had at one versus the other kind of thing, okay? So you can put them side by side on the same little graph or the little chart thing and figure out where the stuff lines up and get information from that. Other stuff that this can tell you that we will get to eventually, it can tell you if it's skewed or symmetric. Based on how it's drawn. I think that might not come until chapter 6 or even possibly later than that, but it can also tell you that information by being able to read stuff off of here. All right, next thing, a time plot. has time as its x-axis. So meaning you've got, like, for example, time of day down here, and we're going to go temperature out here. And so time of day, you can see what happens to the temperature as you go, kind of thing. Let me get this, doesn't have a glare on it. It's just weird today. Sometimes we need to use a simple math function to reinterpret our data to make it more usable. Data that is very skewed can be reinterpreted using exponents or logarithms. Got about probably close to 9 more lines of stuff, depending on how big you draw these little pictures in a second. All right, important little note here. When you compare distributions using histograms or box plots, be sure to compare socks. So I'm going to attempt to draw 2 standing up box plots here. I'll let y'all get those drawn and then we'll talk about them. And my pictures aren't drawn perfectly, so just understand that when I write this, it's just The pictures aren't perfect, but the principle of it is what we're looking at here. All of the data in group 1. Okay, this should really be in line with this median piece here. Is larger than what?
So, you're saying the end of the first one should be in line with what?
Like, really what this should look like is,
Sorry, I didn't mean to-
no, you're good. I really should have it drawn more like this, so that the bottom of one is in line with the middle of the other one, but my drawing wasn't perfect. So depending on how you drew it, yours may not be exactly the same either, which is fine. Just understand it's the principle of it that we're going for. Okay, obviously the book's going to give you much nicer pictures than I'm capable of drawing myself. Because if you haven't noticed, I'm not an art student. Or another thing we could write about is the highest 25% of group 1 is higher than the max of group 2.